In this tutorial, a simple contour curve is created. The curve is controlled by a small set of parameters and generates several different but still related shapes. Only 1/4 of the symmetric contour is modeled and connected to parameters. The remaining part of the contour is then created using image curves as the base contour. For instance, such a basic contour can be used for duct or diffuser design. Another tutorial will show you how to generate advanced parametric surfaces using these kinds of parametric 2D definitions. In the first step, a NURBS curve is created based on 3 points, so-called control vertices, since we want to utilize the weights of a NURBS curve. The weight controls how much the curve is attracted to a corresponding control vertex. Click on the button, Rotate to Z-axis at the 3D view to have a XY plane view. Create a point via CAD, Points and click 3D point. Set the Y coordinate to 0.5. While P1 is selected, press Ctrl and move P1 in positive X direction, this will create another point P2. Set the X coordinate of P2 to 0.5. Make sure that the Y coordinate of P2 is also still set to 0.5. While P2 is selected, press Ctrl again and move P2 in negative Y direction, this will create P3. Set the Y coordinate of P3 to 0. Select P1, P2 and P3, select in this order, and choose CAD, Curves, and click NURBS curve. Set the name of the new curve to Contour. We want to create basic parameters for our contour such as height and width as well as a weight for the inner control vertex. The weight is introduced in this step. Create a parameter for the second weight of contour, by highlighting the second value 1, and choose Create Parameter. Set the name of the new parameter to weight. Try out different values for weight. Finally, set the value of weight to 1 divided by square of 2, which generates a circular arc. Let's add some further parameters for height and width. Since we model only 1/4 of the total contour, we need to divide the parametric coordinate values of the points by 2. Select P1 as well as P2 using Ctrl and create a parameter for the Y coordinate via the context menu. Set the name of the new parameter to height. Set the value of height to 1. In the Y coordinate of P1 and P2, divide height by the factor 2. This is only 1/4 of the entire contour. In the same manner, create a parameter for the width of the contour, select P2 and P3 using Ctrl and create a parameter width for the X coordinate. Set the value of width to 1. Divide the X coordinate by 2. So far, the 3 parameters weight, height and width control the shape. We need to create the remaining parts of the contour in order to finalize it. For this purpose, image curves are created. Select Contour and create an image curve via CAD, Curves, Image Curve. Set the name of the new image curve to Contour 2. From the pull-down menu of Image Transformation, create a scaling transformation. Set the name of the new scaling object to Scale 2. set factor y to -1. Now, the next curve, select contour 2 and scale 2 using Ctrl. Copy and paste this selection which creates contour 3 and scale 3. For scale 3, set factor x and factor y to -1. Finally, the last curve, select contour 2 and scale 2 using Ctrl. Copy and paste this selection which creates contour 4 and scale 4. For scale 4, set factor x to -1. Finally, all 4 curves are put into a polycurve which then represents the complete parametric contour. Select contour, contour 2, contour 3 and contour 4. The order of the selection is important. Choose CAD, Curves, Polycurve and set the name of the new curve to Total Contour. Activate the option Auto Orientation so that the input curves are sorted automatically according to their orientations. Change the contour parameters to receive different shapes. The contour, in this example, is rather simple and introduces some basic modeling issues of FFW such as introducing parameters and curve orientations. Although the geometry is simple, the applications can be quite sophisticated, for instance, when such geometries are used for meta-surface design. There is a follow-up tutorial which is based on this contour. It shows how to create an advanced sweep surface by utilizing the parameters that have been introduced here.